Imagine staring up at the night sky. Billions of stars, countless galaxies, all blazing with unimaginable energy. Our own sun, just one star among trillions, is a thermonuclear furnace so powerful it bathes our entire planet in life-giving light. Yet step just a few hundred kilometers beyond our atmosphere, and you are plunged into an endless, profound darkness. Have you ever wondered why? If the sun is a cosmic lighthouse and the universe is filled with countless more, why is the space between them so impenetrably black? The answer will challenge everything you think you know about light, space, and the very fabric of our universe. To understand this cosmic paradox, we first need to rethink what light actually is. We often imagine light as something that fills a space, like water filling a bucket. You turn on a light bulb, and the whole room brightens. But that's not how light behaves in a vacuum. Light is a form of energy, carried by particles called photons. These photons travel in straight lines from their source, like tiny, hyperfast messengers carrying a packet of light. They will keep traveling in that straight line forever until they hit something. Here on Earth, our atmosphere is packed with trillions upon trillions of particles. Nitrogen, oxygen, water vapor, dust, and pollen. When sunlight streams into our atmosphere, its photons collide with these particles. The particles absorb the photon's energy and then re-emit it, scattering the light in all directions. This process, known as Rayleigh scattering, is what paints our sky blue. It's like a cosmic pinball machine where photons bounce around, illuminating everything from every angle. The sky itself becomes a secondary source of light. Without an atmosphere, if you looked up during the day, you would see a brilliant sun set against a pitch-black sky, just like the astronauts on the moon did. There's nothing up there to catch and scatter the light. Think of it like this. Imagine you're in a massive dark warehouse. If you shine a powerful flashlight straight ahead, you'll only see a bright spot on the far wall where the beam hits. The vast space between you and the wall remains dark. Now, fill that warehouse with a thick fog. When you turn on the flashlight, the tiny water droplets in the fog will scatter the light in every direction, and the entire warehouse will glow. Earth's atmosphere is that fog. Space is that empty warehouse. The sun's light is simply passing through, its photons on an uninterrupted journey across the void. Unless your eye is directly in the path of those photons, or they bounce off an object like the moon and into your eye, you perceive only darkness. This explains why the immediate space around Earth is dark. But what about the bigger picture? The universe is filled with an estimated 2 trillion galaxies, each containing hundreds of billions of stars. Surely with that much starlight, the entire night sky should be ablaze with light, as bright as day. This very question puzzled astronomers for centuries, and it became known as Olbers' paradox. If the universe is infinite, static, and uniformly filled with stars, then no matter where you look in the sky, your line of sight should eventually end on the surface of a star. The whole sky should be a solid, blindingly bright sheet of light, but it isn't. So what's wrong with the assumptions? The resolution to this paradox is one of the most profound discoveries in human history, and it has to do with the birth and evolution of the universe itself. The first flawed assumption is that the universe is static and eternal. In the 1920s, astronomer Edwin Hubble made a groundbreaking observation. Galaxies are moving away from us, and the farther away a galaxy is, the faster it's moving. This discovery proved that the universe is not static, it's expanding. This expansion has a dramatic effect on the light traveling through it. As space itself stretches, it also stretches the wavelength of the light traveling through it. This phenomenon is called cosmological redshift. Imagine a light wave traveling from a distant galaxy. As it journeys across billions of light-years of expanding space, its wavelength gets stretched out, shifting it from the visible part of the spectrum towards the red, and then into the infrared, microwave, and radio wave parts of the spectrum. Our eyes can't see these longer wavelengths, so the light from the most distant objects in the universe is still reaching us, but it has been redshifted out of the visible range. It's there, but it's invisible to us. The sky is, in fact, glowing with this ancient light. If we had eyes that could see microwaves, the entire sky would be glowing with the faint, uniform afterglow of the Big Bang. The cosmic microwave background radiation. It's the oldest light in the universe, stretched over 13.8 billion years into invisibility. The chai. Second part of the solution is that the universe is not infinitely old. It had a beginning, approximately 13.8 billion years ago. Since light travels at a finite speed, the cosmic speed limit, it means there's a horizon to what we can see. We can only see light from objects whose light has had enough time to reach us since the beginning of the universe. This observable universe is a sphere about 93 billion light-years in diameter, with us at the center. Any star or galaxy beyond this horizon is, for now, completely invisible to us. Its light simply hasn't had the time to complete the journey. So, there are vast regions of the sky where our line of sight doesn't end on a star because the light from those distant stars is still on its way. So here is the crucial revelation. Space isn't black because it's empty. It's black because the universe is expanding, and it had a beginning. The darkness of the night sky is not a sign of emptiness, but a direct, visible consequence of the Big Bang and the finite age of our cosmos. It's the ultimate evidence for our cosmic origin story, written in the absence of light. The darkness is a relic of a time before the stars were born, and a message from galaxies so distant their light has been stretched into invisibility by the expansion of space itself. It's an astronomical crime scene, where the clues are not what we see, but what we don't. The simple question of why is space dark leads us to the very edge of our understanding of reality. It connects a simple observation to the grandest theories of cosmology. The darkness isn't a void, but a canvas filled with invisible colors of red-shifted light and echoes of the cosmic dawn. It's a humbling reminder that what we see is just a tiny fraction of what's really out there. Every time you look up at the night sky, you are not just seeing stars. You are seeing the evidence of an expanding universe with a finite past. The darkness is just as important as the light. Thank you for joining us on this journey through the cosmos. If this exploration of the universe's greatest mysteries sparked your curiosity, please hit the like button and subscribe to our channel for more deep dives into science and space. And be sure to check out our other video on what lies beyond the edge of the observable universe. We'll see you in the next one.